Now, as we have seen, it's quite challenging to do the calculations, and you need to do a lot of data manipulation just for a simple standard curve. So maybe there is an easier way of dealing with that. So we need to set up the standard curve, we need to calculate then the means, and we need to define this uncertainty area here. And that is rather involved. So therefore, I've decided to write a little program, and the link to this program is in the description to this video down there, where you can actually just simply enter your x values, your y values, and your unknown samples. And the program will calculate that. So here is basically the program where you can let the program estimate the 95% confidence interval for reading from a calibration curve. So in the first place, it will ask you how many data points does your standard curve have. Our curve has 9, and the unknown samples, we have 3 data points for the unknown sample. So all you need to do is really, you need to type in the x values for your standard, and then the y values. The x values in this case would be the glucose concentration, the y values would be the absorbance, and the unknown samples, this is the absorbance of the unknown samples, and we just simply let the program calculate everything. And again, we get here our slope and the intercept. We get the mean of the sample observations, we get a standard error, and most importantly, the program calculates this 95% confidence interval. And I'll just simply copy that, the 95% confidence interval for our standard, for our unknown samples here. So let's go back to Excel and compare that with what we have done previously. So previously, when we just used the standard curve, the line of best fit, we got 20.2 plus minus 1.2 microgram per milliliter. Now, with the help of this little program, I just simply copy paste in here. So we would get, and I make this a little bit bigger so that we can easily see this, we would find 20.198 and plus minus what did we get? 2.205. And now we would need to adjust the significant figures. So we would adjust that to 2.2 with 1 decimal. So we would report when we use the confidence interval of the standard curve, we would report this to 20.2. And again, I make this a little bit larger. 20.2 plus minus 2.2 microgram per milliliter in this case. So this result here is when we take the uncertainty of the standard curve into account. So Let me write this down. This is with the uncertainty of the standard curve included. And this one here was without the uncertainty of the standard curve included. This only included the uncertainty of the samples. So uncertainty of samples. But it did not include the uncertainty of the standard curve. This here had the uncertainty of the standard curve included, and of course it has the uncertainty, let me spell this out, plus uncertainty of the sample. And we actually notice that there is a difference in terms of what our result would be. So here we would expect our samples to be anywhere from 19 to 21.4 micrograms per milliliter. Whereas in this case, the uncertainty is larger, and we would expect anything from 18 to 22.4 micrograms per milliliter. This is just simply because we take into account here the uncertainty that we also get from our standard curve. And it's very clear that the really proper and right way is to do it with this way. I understand it's a little bit more involved, but with this little program, for which I put the link into the description of the video, there is no problem in easily calculating that. So I hope this makes sense, and thank you very much for watching.